Okay, our third method for solving a system of equations is what we call elimination. Also, I've heard it called the addition method. What the basic premise here is that we're going to try to eliminate one of our variables. We know we can't solve for x and y at the same time, so if we can eliminate one, we can solve for the other. I'll walk you through it. We're looking at the system of equations, and we want to try to get our x's and our y's to cancel out. So right now I'm looking at 2x and 12x. Don't cancel. Negative y, positive 4y. Don't cancel. How are they going to cancel? They're going to be the same number, but opposite signs, just like if you're solving an equation. So I'm going to go ahead and just start with the first equation. I want to make the 2x make into a 12x, but I want it to cancel, so I want to make it into a negative 12x. So I'm going to multiply the first equation by negative 6, and I said the first equation because I can't just multiply the x term. I'm going to rewrite the whole equation, so I'm going to literally distribute the negative 6 through the whole equation, giving me a negative 12x. Negative 6 times negative y plus 6y equals negative 36. Second equation, I'm going to rewrite exactly as it is. Remember, I wanted the x's to cancel, so I have to keep that a positive 12x, because now I have a negative 12x for the first one. Plus 4y equals negative 4. And I literally add the two equations. Negative 12x plus 12x cancels out. 6y plus 4y giving me a 10y. Negative 36 plus negative 4 giving me a negative 40. At this point, I'm ready to solve for y. Divide and I get negative 4 for the first part of my solution, because remember, our solution is going to be an ordered pair, and we just found the y coordinate of that ordered pair. Second step, I now have the y value. At this point, it really turns into the same last step as when we're using substitution. We need to plug our y value into either of our original equations, and then we can solve for our x value. I'm going to take the first equation just because it looks a little bit simpler to me. I don't have a coefficient to my y, so 2x minus y equals 6 was my original equation. 2x minus, instead of writing y, my y is negative 4, so I'm going to plug that in. Negative 4 equals 6, and I'm just solving for x. So I'm going to simplify that to 2x plus 4 minus a negative is plus a positive. And 2x equals, whoops, subtracting 4, not adding, giving me a 2. So I get x equals 1. And now I have the second part of my solution, the x value for my coordinate pair. Okay, remember you can plug those both back into both equations. And when you plug in the 1, negative 4 into your first equation and the 1, negative 4 into your second equation, it should come out that you have two true equations. Just to give you a quick look, what we are doing graphically, we are finding the point of intersection of two lines. And I already did this problem in a different video by graphing, so you can watch that for the whole solution, but I can show you real quick. The 1, negative 4, it was the same problem. Our point of intersection is right there. Before we're done, we're going to do one more problem because there is a harder case of elimination. Okay? When I'm looking at this system of equations, I still like elimination. It would be my first choice because neither of those equations would be very easy or pretty if I tried to solve for one of the variables. I'd end up with some pretty ugly fractions. Okay? I also like how everything's lined up. And if it's not lined up, that would be my first thing I would do, is I would line up my x terms, my y terms, and my number terms, and make sure your equals also line up. Okay? So that's looking nice. What I don't like about this is that none of my coefficients work out nicely. In other words, I can't multiply 3 by anything to get 5 to try to get my x terms to cancel out. Likewise, 2 and 7, 2 does not multiply by anything to get 7. So what I'm going to have to do is I'm going to have to multiply both equations by something. Just to show you that we can do it, I'm going to go ahead and try to cancel out my y's instead of my x's this time. Okay, you could do either one. So my least common multiple between 2 and 7 is going to be 14. Therefore, I'm going to go ahead and multiply the first equation by, you can do positive or negative. Let's go ahead and do positive 2 for the first one. That'll give me a positive 14. Okay, I'm going to rewrite that. So I've got 6x plus 14y equals 30. And now the second equation, I want to get a negative 14 for my y term, so I'm going to have to multiply that by negative 7. Okay, and again, you could have done negative 2 and positive 7, that's fine. Multiplying everything, so I've got negative 35x I've got a negative 14y equals negative 7 times negative 4, positive 28. And I'm now ready to go ahead and add the two equations. Okay, 6x minus 35x gives me a negative 29x. 14y minus 14y, cancel out, equals 30 plus 28, giving me 58. Stop right there. At this point, if you have two variables in your equation, you did something wrong. Okay, you were supposed to get one of them to eliminate. So double check. I'm good to go. It's a quick division at this point, giving me a negative 2 for my x value. Just to finish it off, second step is I would take one of the two equations that I have. I'm going to go ahead and grab the second one. This time I've got 5x plus 2y equals a negative 4. This time I have my x variable is what I solved for. So I'm going to take that one and plug it in right here, which is what I'm multiplying by the 5. 5 times a negative 2 plus 2y equals a negative 4. Do the math, giving me negative 10 plus 2y equals negative 4. 2y equals a positive 6, giving me y equals 3. For my second part of my solution, I would say that my final solution, I'm assuming that you will want to put your answer into a coordinate form, is negative 2, comma 3. Okay, of course, we could graph this to double check it. We could also plug in the negative 2 and the 3, double check that they work in both equations. I forgot to mention when we were on the first example that we could have eliminated, just kind of a good recap of how we actually start this problem. We could have chosen to eliminate our y's instead of our x's. And if you follow me for a second, whoop, didn't want to do that. Come on. If you follow me for a quick second, if I was going to eliminate my y's, I have a positive 4y is the bigger one. I would have to multiply the first equation by what to get my y's to cancel out? And if you just said 4, you've got the concept. That would give me a negative 4y to cancel with my positive 4y. Okay, try a few of those problems. See how it works. I would say elimination is probably the easier method in a lot of cases. Definitely worth your time to learn if you don't want to deal with fractions, because substitution can end up with some crazy problems because you're always going to have to solve for one variable.